Yes, welcome back. And as promised, let us do some questions on how to find the inverse functions and to get better at this. So which of the following functions, if I take this question, which is from the IB book, which of the following functions have inverses? Where an inverse exists, write down the inverse function. So now the function is not given exactly, it is given as in the form of ordered pairs. We don't have a graph, we don't have any fx here, but we have ordered pairs. And if we started with the definition of function, if you go back and see that video, we only started with this idea to build the concept of what is the function. So we know that inverse will only exist if the function is one-to-one function. For many-to-one function, the inverse will not exist. Therefore, let us see each one of these, whether these are one-to-one or not. And if they are one-to-one, they will have inverse and therefore be able to write the inverse. Now, what happens for one-to-one? What do we see? First, look at the x values. First, we'll see whether it's a function itself or not. Then we will look whether it's one-to-one or many-to-one. So for looking at whether it's a function or not, look at the x values. Are the x values different? Yes, all the x values are 1, 2, 3, which are different. Now look at the y values, whether y's are also different. If y's are also different, then it's a one-to-one function. Yes, y's are 2, 4, 5, which are different. So this will have an inverse. And what is going to be the inverse? Just interchange the x to y to inverse. 1, 2 will change to 2, 1. 2, 4 will change to 4, 2. And 3, 5 will change to 5, 3. Right? If I look at the B part, x's are all different. What about the y's? We have 3, we have 2, and again 3. Oh, it's a many-to-one function. Many values of x are mapped to the same value of y. Namely, -1 and 1 are both mapped to 3. So this will not have an inverse. C part, if I look at all the x values, they're all different. Look at the y values, 1, 0, 2, 3. Yes, it again has an inverse. And we can interchange x and y to write the inverse function. This again, -1, 0, 1, and y values are also different. Again, it has an inverse. And if you write the inverse now, it will be the same only. Why? Because -1 is mapped to -1. So if I reverse -1 and -1, it again becomes -1 and -1. So it is called these functions are called self-inverse function. Self-inverse. Self-inverse means you get the same function even after inverting the function. So such functions are called self-inverse functions. So this is one way or one type of question that you should know. Second type of question is something that we see here now. The diagram shows the function which you see is a many-to-one function. It's a parabola which has got a vertex. What's the vertex of this parabola? Vertex is going to be, 2, 1, because this is already completed the square form. Right? And x belongs to the set of all real numbers. So we can know it's what is called a many-to-one function, and therefore it will not have an inverse. Right? But the domain can be restricted to make the inverse and then write the. So let us see. What is the first kind of question? What type of mapping is this function? It's a many-to-one. What are the coordinates of the vertex? I have already given you 2, 1. What is the domain of the function? Domain of the function is x belongs to the set of all real numbers. What is the range of the function? Now to look at the range, which we have done already in the another video, x minus 2 whole square is always positive. So can we say the range is fx will always be greater than equal to 1? Because I'm adding a positive value or a 0 value to 1. So either it will become 1 or more than 1. Does this function have an inverse? No. If f has an inverse, what is it? If not, then how could you change the domain? Yes, we could change the domain in 2 ways. Either I can put the domain as x less than equal to 2, in which case I am taking this away. This part is gone, right? And then we can write the inverse, or I can have x greater than equal to 2. So what is important is the x coordinate of the vertex if we have to write the inverse of a quadratic function. So either it could be x less than equal to 2 or x greater than equal to 2. If x is greater than equal to 2, then I'm taking away this left part of the graph or left of the vertex and keeping the right part and therefore be able to write. So let's take one of these and write the inverse. Let's take the first one. So I have the same function with me, but now the domain is x less than equal to 2. Isn't it right? So x less than equal to 2 means the right part is gone. So this part you can forget. This is the function. And the graph is like this. And we want to write the inverse of that. So what are the steps? The steps are again the same. The very first step is make fx as y. So y is equal to x minus 2 whole square plus 1. The second step was interchange x and y. That's what I'm going to do. And now make y the subject. Y the subject means I will have to do x minus 1 is y minus 2 whole square. And therefore y minus 2 whole square becomes x minus 1 again. I mean, I can take the square root here plus minus. When you take the square root, it becomes a many to one function, isn't it? Because we have plus also and 1 also, isn't it? Y minus 2 is plus also and minus. Can I add 2 on both sides? So y becomes 2 plus minus. Now the question is, either I have to keep this plus or the minus sign. I can't have both. So which will I keep and which will I drop? Look at this. Look at this. This tells you what y value we're going to get for inverse. Now this is the inverse function. But still we have to remove one of the sign, either plus or minus sign. So x is less than equal to 2, which is the domain of the given fx. Domain of fx is x less than equal to 2. So the range of f inverse should also be that f inverse should be less than equal to 2. In which case, should I keep the plus sign or the minus sign here? If I keep plus sign, it will become 2 plus something. So it becomes 2 more than 2. I want to be range to be less than equal to 2. So I'm going to drop the plus sign and keep the minus sign only. So your f inverse finally becomes 2 minus under root x minus 1. And the domain of this function is going to be now domain of f inverse is going to be, x is to be greater than equal to 1 because this is x minus 1 and we can't take square root of a negative number. And that is the domain. And what was the range of this f function fx? Range of fx was also, we wrote greater than equal to 1. See here. Range of fx is the same as domain of f inverse. Greater than equal to 1, here also greater than equal to 1. What was the domain of fx? Domain of fx was x less than equal to 2. And we got the range of f inverse also less than equal to 2. So we have been able to find the inverse, and we also verify that the domain of fx is the range of f inverse. And the range of f inverse or the range of fx is the domain of f inverse. I hope this makes the things very clear because this is what is going to be an issue with many of the quadratic functions, how to write the inverse. Because if we take x belongs to R as the domain, then the inverse does not exist. But if we restrict the domain to either the left side of the vertex or the right side of the vertex, then we will be able to write the inverse function. So taking one more question here, I think, yeah. So if we take one more question, which is going to be somewhere like this, which is again the quadratic only, but it becomes now much easier than the previous question. Fx is this, x greater than equal to 0. Yes, we know what is the vertex of this function. The vertex of this fx is 0, minus 3. So he has taken now x greater than equal to 0. So we are retaining the right part of the graph and we are dropping the left part of it. What is f inverse? So first, again, the same steps, write y as x squared minus 3. And then interchange, x becomes y squared minus 3. So y squared becomes x plus 3. If I take the square root, it becomes plus or minus square root of x plus 3. Now, because I want x to be greater than equal to 0 as the domain of fx, so range of the function f inverse will be also greater than equal to 0. So we'll keep the positive sign, right? Because the domain of fx is x greater than equal to 0. So range of f inverse should also be greater than equal to 0. And therefore, I can't take the minus sign because minus sign will make it less than 0, a negative number. So this is how it is. But the domain here, domain of this function is x greater than equal to minus 3, which you can also see is the range of fx. What is the range of fx? A positive number added to minus 3. So range of fx is fx greater than equal to minus 3, which is also coming here at the domain of fx. Right? And that is how we can. Thank you very much. Thank you.